Okay, Assalamu alaikum and hello students. This is our tutorial number 5 and we will solve some problems related with moment of force and a couple of problems related with center of mass of compound shapes. So let us start. In this first problem, the example shows a wrench being applied to a nut. So this is the nut with a 100-pound force. So 100-pound force is being applied here on this end, and at point C, the center of the nut. So this is the center of the nut about which it will rotate. The applied force is at an distance x of 12 inches. So the force, this red arrow, is the force. It is representing the force F. It is being applied on the nut at a perpendicular distance of 12 inches. So notice the units here. The force is given in pounds and the distance is given in inches. Okay, the center of moments could be point C, but also can be points A or B or D. Now in this example, actually we have to calculate the moment of force about point C as well as point A, B and D also. Okay, so each of these have different moment arms and different locations in the figure. So the values are also given. From here we can calculate the moment arms about from each axis of rotation or the point of rotation. So first we need to write. Okay, so we can write our given data. Here, very simple. First, force, applied force, is given as 100 pounds. So it is not necessary to use this symbol because only magnitude is given. So 100 pounds is the force, and you know pound is represented with LB. The symbol is LB, and the moment arm from C, from point C. So we call it D with a subscript C to show its affiliation with respect to C. So this is 12 inches. Okay, so we can write it like this. Now we have to find out the moment arm. To find is moment, so sorry, not the moment arm, we have to find moment of force. Can call it capital M with respect to C, with respect to A, and with respect to B, and also with respect to point D. Okay, so all of these. And we also know the formula. The formula is M moment is equal to F times D. D is the moment arm and F is the applied force. So by using this formula, we can easily calculate moment against a moment about a certain point. Let me clear it all. Okay, first is moment about point C. Moment about point C can be calculated like this with a small subscript C. So F remains the same times DC. So F is 100 pounds multiplied by DC, that was this one, from here until here. So this is the vertical distance between C and the applied force, between the point C and the applied force. So this is 12 inches. So it is going to be 1200 pounds inches. Okay, this is the moment about point C. Similarly, we can find moment about point A. For this, we call this MA F times dA. So this is the distance between point A, this one, and the applied force. This is dA. This one was dC. So the applied force remains the same, which is 100 pounds times dA. dA is 8 inches here. So as you can see here, it is 8 inches. So we can write it like this, or we do not need to write unit as yet. So it is 800 pounds inches, right? So this is the moment of this force about point A. Now we have calculated moment of the applied force about point C and about point A. So then two more points are left, point D and point B. So if you can see, the moment is equal to the force, applied force, and the distance between the applied force and the center of moments, or the center of rotation. So D is the center of rotation here, and this red is the applied force. Since both of them along the same line and there is no distance between them, so the D, or moment arm, will be equal to 0. So if D, okay, I will write it here. This is number 3, moment about point D. So it is M, D is equal to force times D and with small d. So F remains the same, 100 newtons times D, the distance between the vertical distance between this and this force. So there is no distance, it is 0. So the moment about point D is 0, right? And now between point B and the force, so this is only 2 inches. Now you have to do it yourself. Okay, the final one I leave it to you. Fourth one, moment about point B. So do it yourself. Okay, so I leave it to you. Okay, now an example related with center of mass. You have done it before, means you have studied how to find out center of mass. I gave you an activity also. Now you have to submit that activity after I give you the due date. Now in this example, we are given a system of masses, 3 flat objects, uniform density. These 3 objects are of uniform density. Find out the center of mass of the system. So this full is the system, okay? And this is the mass distribution of 3 objects laying on it, okay, at certain distances from each other. They are of uniform density and they're flat objects of regular shapes. So this graph one means these grid lines, these are to help finding out the distance. So here for simplicity we take units in terms of square of boxes. Instead of measuring these in terms of inches or centimeters or meters, we count them in terms of boxes. So the distance of this one from the origin can be represented as 1, 2, 3, 4, 5, 6, 6 boxes, okay, and from towards y 1, 2, 3, 4, 5, okay, so this is 5 boxes, okay. So similarly this one we can do it in a similar way. This one is from, because we have to write down its coordinates of the center of each of these, okay, in order to find out the center of mass. So we consider this is the center of mass of each of this object, because in order to find the center of mass of a system, we have to find the coordinates of the center of mass of each object, okay. So if this is the center of mass, then its coordinates can be written like this. First is the x, distance from origin, horizontal distance, it is 1 box, 2 box, 3 box and 4 boxes. So it is 4, comma, y-axis is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. This is 12. Now for this one, its center is here. Okay, this one, now we start counting from x, 1, 2, 3, 4, 5, 6. So it is 6, its coordinate is 6, and vertical is 1, 2, 3, 4, and 5. This is 5. Okay, now for the third one, its center is here. Now we can notice that it is not exactly in the middle. It is not exactly on the cross of 2 boxes. Okay, so from horizontal it is 1, wait, so it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this is 12. You can write here 12, and vertical one is 1, 2, 3, 4, 5, 6, 7, 8 and 9. It is somewhere 9.5, because it is not exactly at the crossbar, at the cross of the line. So it is in the middle. It is in the middle somewhere. If you draw a line here, you will see it is in the middle. So that is why 9.5. Okay, now once we have calculated, means once we have measured these coordinates of these masses, the next step, you know what the formula is. So we need to use formula for the center of mass of the system. So for x coordinate, center of mass x, it is the distance times the distance times the mass. So I call this one as m1, I call this one as m2, and this one as m3. So it should be m1 times x1 plus m2 times x2 plus m3 times x3, okay, and divided by m1 plus m2 plus, sorry, m3. Okay, so m1 is 1 kilograms times x1 is 4 plus m2 is 2 kilograms times 12 plus m3 is 1 kilogram times 6 divided by 1 plus 2 plus 1. So 1 times 4 is 4 plus 2 times 4, 2 times 12 is 24 plus 6 divided by 4. So it is 34 divided by 4. So it gives us, let me calculate. So it is 34 divided by 4 is 8.5. So our COMX coordinate is 8.5. Okay, now I am going to erase it all. Now we calculate center of the y coordinate of center of mass. In a similar way, COMY is equal to M1 times Y1 plus M2 times Y2 plus M3 times Y3 divided by M1 plus M2 plus M3. So M1 is 1 kilogram times 12 is the y coordinate, plus M2 is 2 kilograms times 9.5 plus M3 is 1 multiplied by 5. Okay, divided by same thing, 1 plus 2 plus 1, and we get 12 plus 2 times 9.5 is 19, and plus 5 divided by 4. So it gives us 19 plus 12 plus 5, 36 divided by 4. So it is 9. So y coordinate of our COM is 9. This is 9. Therefore, now we'll count first x, which is 8.5. 1, 2, 3, 4, 5, 6, 7, 8. This is 8 and this is 8.5. Okay, and from, sorry, it is wrong. So x, it is 8.5 and y is 9. First we see 9. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is 9, and we have to go towards horizontal by 8.5. 1, 2, 3, 4, 5, 6, 7, 8. This is 8 and this is 8.5 here. So this is our center of mass for this system. This is our center of mass and its coordinates. So this is COM and its coordinates are 8.5 and 9. So this is our center of mass for this system of masses. Okay, and in this example, we are given this irregular shape, flat shape of uniform density. Okay, so we are asked to find out its center of mass. So in order to find out center of mass, first we need mass, and then we need coordinate of the systems, or coordinate of the object in the system. So since this is only one object, in contrast to the previous one where we had 3 objects in the system, we have only one object of irregular shape, and with a void in it. Okay, this void does not have any mass here, but rest of the object has uniform mass. The density is uniform. Having uniform density means that the distribution is uniform. It is not thick or thin or dense or more dense or less dense at certain points. So it has uniform mass distribution and uniform density. Sorry. So it has uniform density all across. So in order to find the center of mass for this one, in such a case, the first step will be dividing this object, is this regular object, into irregular object into regular shapes. Okay, the regular geometric shapes, which are rectangle, triangle, squares, circles. After doing that, we can easily find out the center of mass in this of this object with the help of the grids in the background. Okay, so these grids help us measuring the dimensions. Okay, first thing is that, and the second thing, we do not know the mass, so we are not given any mass. We just told that it has uniform density. So instead of calculating, instead of using the mass, we can use the area. Because it's a flat object, we can use the area, and the area will be proportional to its mass because it has uniform density. So larger area has larger mass. right? So if the area of one piece is 2 times to the area of the second piece, the mass will also be twice. So these will be proportional to each other. So that is why we can use area instead of mass. So in order to do that, we can first divide this into some regular shapes. So first we can do it like this, the shapes which can help us finding the area and the center of mass also. So first is this is a rectangle, okay, this rectangle, and then this rectangle, okay, and then this full length, sorry, this one, this rectangle, okay, and this circle. Because this is a void, we need to measure how much is missing, how much of the mass is missing. So for finding the area of this, you know that if this is a rectangle, the area of a rectangle is the length multiplied by its width. So the length can be measured with these boxes behind it. So 1 2 3 4 5 6 7 8. So 8 is this length. Any units can be centimeter, inches, or feet, and 1 and 2 on this side. So its area will be equal to 8 times 2. Similarly for this one, 1 2 3 and 4. 1 2 3 4 5 6 7 8 9 10 11 12 13. So it should be 4, because this was 4 and this side is 13. So it is 4 times 13. So we can write it like this. So the area of this larger rectangle is 4 times 13, and since this shape and this shape are of equal lengths, it is also 8 times 2. Right. So how about this one? It has 1 2 3 and 1 2 3 and 4 on this side. So 3 times 4 of this one. And how about the circle? The area of the circle is pi r square. So pi r square. For this we need to know r. R is the radius of the circle. So we know that radius is half of the diameter. Diameter of the circle is 1 box, 2 and 3 boxes. So if these are 3 boxes the diameter, then radius will be 3 divided by 2, 1.5. So its area will be pi times 1.5 square. Okay. Okay, now we have found all the areas. So these areas we will be using instead of masses here. So in order to find out COMX, since instead of using masses we can use areas. For this one first. Okay, so its area is 16, right? So we can write 16 here. Okay, and then we have to find its center also. So center must be at 4 1 2 3 and 4, this line, and the middle of this line, right? So this is the center of this. We can count now. 1 2 3 4 5 6 7 8 9 10. So x is 10. This one here. So it is 16 where it is. Okay, so it is 16 times 10 plus plus this one. So 1 2 3 and 4. So middle is this line. So we can keep going like this. Sorry. Yes, it should have been here. This one, this line, and from here it is 13. 1 2 3 4 5 6. It should be 6.5 here. Okay, so this is it. Okay, this one, so this is 6.5, and 1 2 3 4 4 and 6.5. So it is 4 on the x-axis. The x coordinate is 4, and 4 times 13 is 52. 52 times 4. Okay, plus this one. This is 3 times 4, 12, and its center must be here in the middle of the 3, and here, this point, this tiny point here. So we can count from here. Okay, 1 2 3 4 5 6 7, 7.5. So it is 7.5 and 12. 12 times 7.5, and then this one is left. So it is, the last one is 8 times 2 is 16, and its x is also the same as the upper one. So it is 16 times 10. Okay. Now divided by 16 plus 52 plus 12 plus 16. So one thing is left here, and that is the area of the circle. So area of the circle, this one. Now what is the area of circle is pi into 1.5 square. It gives us here. Here I will write it. I'm going to write here next one. first. It is pi is 3.14 times 1.5 times 1.5. It is 7.06. So you can call it 7.1. It is 7.1 times its x coordinate 1 2. Okay, is here. So 1 2 3 4 4 and 4.5. So it is 4.5. But what sign? Because there is no mass. This mass is missing. That is why we will use minus sign here. Okay, and we will use a minus sign here also, minus 7.1. So after doing all this calculation, our answer is 6.6. You can do the calculations and then you will get this answer for x coordinate of center of mass. Okay, now we calculate center of mass for coordinate y of center of mass. Okay, for that our masses will remain the same, like 16 times something plus 52 times something plus 12 times something plus 16 times something and minus 7.1 times something, and in the denominator it is 16 plus 52 plus 12 plus 16 minus 7.1 will remain the same. Okay, so I hope you understand this concept of negative 7.1, because there is a hole, so that will means to, in order to subtract this area, we will use minus because this mass is missing. Okay, now we find the coordinates for this one. The y coordinate is it is easy to find, so we come from, because it is a maximum one of 15, so 15 14 and 15 minus 2, it is 13, so it is 13, and in the below one is 1 and 2, this is 2 here, and for 52 this one y is, okay, 1 2 3 4 5 6 7 7.5, so this is 7.5, and 12 this one, y-axis is, it is here, 1 2 3 4 5 6 7, so this is 7. Now after calculation you will get it as 7.4. Now we can locate our center of mass on this 6.6 from x. Okay, 1 2 3 4 5 and 6, so it is 6.6, should be somewhere around here. Okay, I use this magenta color, 6.6, and y is 7.4. 1 2 3 4 5 6 and 7, and it will be somewhere around here. So we draw this line and we draw this line vertically. Sorry. So this is our center of mass. So after doing all this effort, we are able to find out center of mass, right? So these are the coordinates for center of mass. So we can write it like this: CO. That our COM is 6.6 and y is 7.4. These are our coordinates for the center of mass. Okay, this is the last example now. In this example, this is also related to the center of mass. Okay, determine the topple limit for the uniform density object shown in the figure as it is tipped to the right. So we have to find out the topple limit. To what means the topple limit means that to what angle we can push it from the top before it tips over, before it falls down to the right side. So it means that we can push it, or means if we push it a little bit, it will come back to its position, original position. If we topple it further, it will come back. If we push it even more, it will come back. So there will be a limit after which it will tip over. Okay, we have to find out that limit. That will be in the form in terms of angle. So we have to find out an angle after which it will not come back to its original position, but it will tip over. That angle is called as topple limit. In order to do that, the first thing is we need to find out center of mass, because center of mass is the place where its balance lies. So in order to do that, we will use the same technique as before. First we will divide it into regular shapes like this: one rectangle, two rectangles, and three rectangles. Okay, and after that we will find out the center of mass of this object. So once we have found out the center of mass, okay, now in order to calculate, in order to find out its center, or its topple limit, we have to push it from the top to the limit it does not come back. So we have to draw that geometry, and that geometry is, as you remember when we were studying the moments, when we were studying about the topple limit also, that if we push an object to a point where its weight the vertical weight, because the weight also acts on the center of mass. So the weight downwards and the normal force upwards, they come, they cancel each other and they are parallel to each other. Okay, they just come to the on the same line like this one. So if we draw a perpendicular line, straight from this point, exactly, so the weight is vertically downwards. So my line is not straight. So this is mg and this is n, or Fn. So normal force is vertically upward and mg is vertically downward. So they are along the same line. So when this condition happens, they cancel each other's effect, and there is no net torque, or there is no net rotational effect or the moment of these forces. So at this stage, this object is balanced here. So if we push it a little further, slightly further, then there will be a net rotation effect because of this couple, because the weight will go slightly to the right. I draw this box here like this. So if its center of mass is somewhere here, let's say, no, not here, wait. So if its center of mass is here, its weight is downwards here, and the normal force is upwards here. So they are making a clockwise rotation. It is going downwards and it is bringing it upwards. So there will be a net rotation effect in the object in the clockwise direction, and this box will tip over. So similar is the case. This one is slightly there when these both are acting along the same line. So in this condition, this line is the vertical, this is a straight line, and then this is the angle which we have toggled it, okay, or to which we have pushed it. So this is the angle that we want to determine. So in order to determine this was the perpendicular line before that, okay, when it was straight. So the weight has shifted this much, like as I showed last time, when two lines are perpendicular to each other and one is shifted, means one is tilted by a certain angle, the line that is perpendicular to that line will also be tilted by the same angle. So this will also be theta, this one. So from this geometry we can find out this theta, which will be equal to this theta, which we are interested in determining. So if this is theta, this angle, just from the graph in the previous slide, so when this is the center of mass, just forgot, I don't know how. So we just forgot that this is the, it was 6.3 and 7.6 center of mass, coordinates of center of mass. So this one is 7.6, right? So in order to calculate this distance from the boxes, we can calculate this. It is just 0.7 from the measurement of the graph on the previous slide. Okay, so this one makes a right angled triangle. This one is 90 degrees. Okay, so we know this side and we know the side which is opposite to the angle, right? So the side which is opposite to the angle is the perpendicular one, right? So this is perpendicular, and the one which makes a 90 degrees angle with the perpendicular line, that is called base. You must remember that, right? So it is like this. Now I will draw it for you. It is like this. This is theta and this is 90 degrees. We know this side and we know this side. This is 7.6 and 0.7. Okay, so which formula can we use to find out this theta? We can use, here we do not know the hypotenuse. Just remember, we do not know hypotenuse. We know only perpendicular and base. So which trigonometric ratio can we use? We can use tangent theta. Tangent theta will be equal to perpendicular over base. This 0.7. 0.7 divided by 7.6, right? So theta can be determined tangent inverse 0.7 divided by 7.6, and it is equal to 5.26 degrees. So this is the angle which is the topple limit for this shape. Okay, so I hope you understood. That's all for today. So if you do not understand anything, something is not clear, we can discuss it later on Kaizala or during our live class, okay, wherever you like. Thank you very much, and see you again, inshallah.